Hey everyone, it's Justin again. This help video is going to go over how to create the flowchart for the third proof within the additional practice for the triangle proofs part 1 lesson. So this problem says, given that segment EF and segment HJ are parallel and congruent, prove that triangle EFG is congruent to triangle JHG. This is phrasing we haven't heard before, parallel and congruent. But it just means that EF is parallel to HJ and EF is congruent to HJ. We know from the start that if we're proving triangles are congruent, we have 5 options. Side, 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 angle, angle, side, angle, angle, side, and hypotenuse leg. I have not been provided any right angles in the picture, and I haven't been given any information about right angles or perpendicular lines in the problem, so I can eliminate hypotenuse leg right away. We were given one side congruence in the problem, but no other information about sides. We have lots of theorems that can help us figure out new angle congruences, though, especially with parallel lines, but none that can help us figure out new side congruences. And since we can't come up with any more side congruences, we can eliminate side, 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 and side, angle, side. That leaves us with 2 options for proving the triangles congruent. And both of them are going to require that we find 2 angle congruences. I will tell you now that there are actually 3 entirely different ways to solve this proof. There are 2 ways that we can use angle, side, and 1 way that we can use angle, side, angle. I'm going to show you all 3 of them here. Let's start by using our parallel segments to find new angle congruences. I'm going to bring back in my parallel symbols here so I can easily keep track of them. I have 2 transversals between EF and HJ, segment EJ and segment FH. Each of them will create their own angle pairs, so let's look at them one at a time. I'm going to start with FH, so to make my life easier, I'm going to extend my segments and just gray out EJ for the time being so that it doesn't distract me. Now I can see that angles F and H are alternate interior angles. And since EF and HJ are parallel, that means my alternate interior angles are congruent. Now let's take a look at EJ as the transversal and fade out everything else. I can see now that angles E and J are alternate interior angles too, so those would also be congruent to each other. Now that I'm done using them, I'm going to leave out my parallel symbols to keep my picture as uncluttered as possible. To recap, we now have angle E and J being congruent, angles F and H are congruent, and segments EF and HJ are congruent. We could use these 3 congruences with the angle side angle theorem to prove congruence. There's actually one more angle congruence here though. Angle JGH and EGF are vertical angles, so they're also congruent. This gives us 2 more options for our proof because now we can use angle, side. I could either use the side congruence and the vertical angle congruence with either angles E and J or angles F and H. All 3 of these methods would be equally valid. There is no advantage to using one over another. It all just comes down to your preference. If you chose to use angle side angle, you won't need the vertical angle congruence. So let me get rid of that to make my picture easier to understand. Your flowchart should look a lot like mine. I have 1 branch for my angle congruence between angles E and J, and 1 branch for my angle congruence between angles F and H. Notice that my bubble for segment EF is parallel to segment HJ, actually has 2 arrows leading to each of those angle congruences. That's because I need to state that the lines are parallel each time to be able to use the alternate interior angle theorem. It creates this sort of funky connection between my 2 branches that we haven't had before, which I've shown here by coding my statement about EF and HJ being parallel in both orange dashes and blue dots and dashes. There's also a 3rd tiny branch here to state my side congruence. All 3 of those lead to the angle side angle congruence. I can tell that this is angle side angle because my side congruence is included in between my two angle congruences. Let's look at the angle side methods next. The two flowcharts using angle side are going to look almost identical. This one uses angles E and J, so let me get rid of the congruence marks for F and H to make my picture easier to follow. We have one branch for the alternate interior angle congruence, one branch for the vertical angle congruence, and one branch for the side congruence. As always, make sure you're stating each of your definitions for your angle pairs before your congruences. Then the three congruences lead to the triangle congruence by angle side. We can tell that it is angle side because our side congruence is not the included side between the two angle congruences. 2 methods down, 1 to go. For this last method, we'll be using angles F and H instead of angles E and J. The flowchart will look almost identical, but we just swap out those angle names in our left branch. We can again see that this congruence theorem would be angle side because our side is not included between our two angles. No matter which method of proving you choose, make sure that when you write your 2-column proof, the order of your lines is logical. I recommend keeping each of your branches chunked together to make it both easier to organize and easier to follow for a reader. Now that you've seen how to create multiple flowcharts for this proof, it's time for you to put this into action. If you had already made a proof, go back and correct your work now and make your 2-column proof. But if you are struggling to get started, take a break and come back to retry this one on your own without this video. Good luck, and I'll see you next time.